In this video, I'll show you how to reduce the radical radicand of square roots. This is part 1. Just a quick anatomy lesson on a radical. This part right here is called the radicand, that's called the index, and this is the radical sign. In question 1, they ask us to simplify the radicand. They want us to somehow reduce x to the power of 3. To do this, notice that your index is not written. Therefore, we assume that it's a 2. What this tells us is that we need to reduce the radicand x to the power of 3 so that it's a perfect square. And here's how to do that. You take this x to the power of 3 and break it down into x to the power of 2 and x. And what this will do is cause this x to the power of 2 to become simply x. And what's remaining inside of this radical is the remaining x. We have just reduced the radicand from x to the power of 3 to x. Question 1 is done. Let's move on to question 2. Here we have the square root of 50. Now we have to reduce 50. And the way we can do this is once again break down 50 into products of at least one perfect square. So we can break this down into 25 and 2. 25 times 2 is 50. Now the square root of 25 is simply 5. And there is no perfect square for the square root of 2, so we just write down the square root of 2. We've gone from the square root of 50 down to the square root of 2, and that's exactly what we want. So that's the final answer. In question 3, we have the square root of 50 times x to the power of 3. This is essentially a combination of question 1 and question 2. Writing out the question, we have the square root of 50 x to the power of 3. Once again, I'll break down 50 into 25 and 2 and break down x to the power of 3 into x to the power of 2 and x. This is a perfect square. This is a perfect square. This reduces down to 5. This reduces down to x. And what doesn't get reduced are the 2 and the x. That expression right there is the simplified version. Lastly, in question 4, we have 24y to the power of 5. Fortunately, we can break 24 down into 6 and 4. 4 is a perfect square. 6 isn't. So let's start off by writing that. 6 and 4. Similarly, y to the power of 5 can be broken down into y to the power of 2, which is a perfect square, y to the power of 2, and y. So if we write down y to the power of 2, y to the power of 2, and y, let's start with the 4. The square root of 4 is 2. The square root of y squared is y. The square root of this y squared is also y. And we're left with 6 and y. You can combine these two to get 2y to the power of 2, the square root of 6y. Also, what you could have done is broken down y to the power of 5 into y to the power of 4 and simply y. The square root of y to the power of 4 is y to the power of 2. And so there you have it. 4 examples on how to reduce the radical radicand of square roots. Make sure to watch part 2 for some more complicated examples.